Hey there, science fans. Welcome to an exciting journey where science meets technology. Today, we're diving into the fascinating world of programming. It's a realm where creativity and logic come together to create solutions that can change the world. Now, you might be thinking, what does programming have to do with science? Well, the answer is quite a lot, actually. Hold on to your lab coats. Because programming is an incredibly powerful tool that helps us understand and solve complex scientific problems. It's like having a superpower that allows us to manipulate data and create models that can predict future outcomes. At its core, programming is all about giving instructions to a computer. These instructions are precise and must be written in a language that the computer can understand. These instructions, written in a specific programming language, tell the computer what to do with data. There are many programming languages out there, each with its own strengths and uses. Think of it like a recipe. You have your ingredients, which is the data, and a set of instructions or code that tell the computer how to combine and process them to create a delicious dish, which is the output. Just like in cooking, the quality of your ingredients and the precision of your instructions can greatly affect the final result. Programming is used everywhere in science and engineering. It's the backbone of many modern technologies and scientific discoveries. From simulating the movement of galaxies to modeling the spread of diseases, programming helps us analyze data, test hypotheses, and design new technologies. It allows scientists to run experiments in a virtual environment, saving time and resources. Whether you're a biologist studying DNA sequences or an engineer designing a bridge, understanding the basics of programming can give you a huge advantage in your field. It opens up new possibilities for research and innovation. So, if you're ready to unlock the power of programming, let's get started. This journey will not only enhance your problem-solving skills, but also give you a new perspective on how technology can be used to tackle real-world challenges. In the next few sections, we'll explore some fundamental programming concepts that will help you on your journey to becoming a programming pro. We'll cover everything from basic syntax to more advanced topics, ensuring you have a solid foundation to build upon. So grab your keyboard and let's dive into the world of programming together. In the world of programming, data is king. Data is the fundamental element that drives the functionality of any software application. Without data, programs would have nothing to process, analyze, or manipulate. But just like we need containers to organize our belongings, we need ways to organize data in a computer's memory. Imagine trying to find a specific item in a cluttered room. It would be a nightmare. The same principle applies to data in programming. We need efficient methods to store and retrieve data, ensuring that our programs run smoothly and effectively. This is where the concept of data structures becomes essential. That's where data structures come in. Data structures are specialized formats for organizing and storing data. They allow us to manage large amounts of data efficiently, making it easier to perform operations like searching, sorting, and modifying data. Data structures are like containers for data. Just as you wouldn't store your clothes, books, and kitchen utensils in the same box, you wouldn't use the same data structure for every type of data in your program. They provide a way to store, organize, and access data efficiently. By choosing the right data structure, you can optimize the performance of your program, making it faster and more efficient. There are many different types of data structures, each with its own strengths and weaknesses. Just like there are different containers for different purposes. Some are better for quick access, while others are designed for efficient storage. Just like you wouldn't use a tiny jar to store a large amount of flour, you wouldn't use a data structure that's not suited for the type of data you're working with. Choosing the right data structure is crucial for the efficiency of your program. Imagine you have a bunch of ingredients for a recipe. You wouldn't just throw them all in a pile, would you? No way. You'd organize them to make the cooking process smoother and more efficient. You wouldn't just throw them all in a pile, would you? No way. You'd use different containers to keep them organized. This makes it easy to find what you need when you need it and ensures that everything is in its place. You'd use different containers to keep them organized. This is exactly what data structures do for your data. They help you keep everything in order, making your program more efficient and easier to manage. You might use an array to store a list of ingredients, allowing you to access each item by its index. Arrays are great for storing data that needs to be accessed in a specific order. A queue to represent the order in which they need to be added, ensuring that the first item added is the first one to be used. Queues are perfect for scenarios where order matters, like processing tasks in a specific sequence, or a tree to organize them by category, making it easy to find related items quickly. Trees are excellent for hierarchical data, where relationships between items are important. Some common data structures include arrays, which are simple and efficient for storing ordered data. Linked lists, which allow for efficient insertion and deletion of elements. Stacks, which follow a last-in, first-out LIFO order. Queues, which follow a first-in, first-out FIFO order. Trees, which are great for hierarchical data, and graphs, which are used to represent networks of relationships. Each data structure has its own way of storing and accessing data, and understanding these differences is crucial for writing efficient and effective code. Choosing the right data structure can make a significant difference in the performance of your program. Understanding these differences is crucial for writing efficient and effective code. By mastering different data structures, you can tackle a wide range of programming challenges with confidence. In the next section, we'll take a closer look at object-oriented programming, a powerful paradigm that helps us organize and structure our code. Object-oriented programming allows us to create modular, reusable code, making it easier to manage and maintain complex software systems. A powerful paradigm that helps us organize and structure our code. By understanding and applying object-oriented principles, we can create more robust and scalable software solutions. As our programs grow larger and more complex, it becomes increasingly important to organize our code in a way that is easy to understand, maintain, and extend. Without proper organization, our code can quickly become a tangled mess, making it difficult to debug and enhance. This is why adopting a structured approach to coding is crucial for any developer aiming to build scalable and efficient software. This is where object-oriented programming, or OOP, comes in. OOP is not just a buzzword. It's a powerful paradigm that helps us manage the complexity of large code bases by breaking them down into more manageable pieces. OOP is a programming paradigm that emphasizes the use of objects, which are like blueprints for creating instances of data structures with specific properties and behaviors. These objects can interact with one another, making it easier to model real-world scenarios in our code. Imagine you're building a car. In OOP, you wouldn't write code for each individual car part. Instead, you'd create a blueprint or class for each part, such as a wheel, engine, or seat. This approach allows you to define the characteristics and functionalities of each part in a centralized manner. Each blueprint would define the properties or data and behaviors or methods of that part. Properties are the attributes that describe the object, while methods are the actions that the object can perform. For example, the wheel class might have properties like radius and width, and methods like rotate and inflate. These properties and methods encapsulate the data and functionality related to the wheel, making the code more organized and easier to manage. Once you have your blueprints, you can easily create multiple instances or objects of each part and assemble them into a complete car. This modular approach allows you to reuse the same blueprints to create different cars with varying specifications. OOP makes our code more modular, reusable, and easier to maintain. By encapsulating data and behavior within objects, we can isolate changes to specific parts of the code without affecting the entire system. This modularity is particularly beneficial when working in teams, as it allows different developers to work on different parts of the code base simultaneously. By breaking down our code into smaller, self-contained units, we can easily modify or extend our programs without having to rewrite large chunks of code. This not only saves time, but also reduces the risk of introducing new bugs. Additionally, OOP promotes code reusability, allowing us to leverage existing code for new projects, thereby increasing our productivity and efficiency as developers. We've talked about data structures and how they help us organize data, but where is all this data actually stored? The answer is in the computer's memory. Memory allocation is the process of assigning blocks of memory to store data used by our programs. When we create a variable or an object, the computer reserves a specific location in memory to store its value. Think of memory as a giant warehouse with many storage units. Each variable and object we create gets its own storage unit. There are two main types of memory allocation, static and dynamic. Static allocation assigns memory at compile time, meaning the size and location of the data are fixed before the program runs. Dynamic allocation, on the other hand, allocates memory during program execution, allowing for more flexibility. Understanding memory allocation is crucial for writing efficient and error-free code. If we're not careful, we can run into problems like memory leaks, where memory is allocated but never released, or segmentation faults, where we try to access memory that doesn't belong to our program.